All right, good evening, everyone. It looks like not a lot of people found the stream yet. I'm hoping that's going to change in a second, but yeah, it looks like the first people are pouring in. So this evening, it's a different setup. I might sound different because it's a different mic. And we are also doing something different than we're usually doing. We're not building a 3D printer. We're not assembling anything. We're not doing anything really 3D printer specific, working on the hardware. We are working on something to print. We are working on models that we can print and use, because that's one of the common complaints. Hey, you have this 3D excuse me, you have this 3D printer, stop printing crap. Adafruit posted a video or shared a video about that recently. It's a common theme. Please don't print calibration cubes and benchies and low poly Pokemon. I'm not going to judge you for that one, but just try not to waste your plastic or waste your printer's capabilities. As I have the fidget spinner open right here. But yeah, that's not what we're going to be making today. We are going to be making cable organizing hardware, a complete set as much as possible. I do have chat open on the second screen, so I can sort of see what you guys want to see, what you want to, what hardware you'd want to see available. I know there is a lot of this probably already out there on Thingiverse, but I just, this is more of a, not specifically Onshape. I am pointing at the screen that I have the Onshape window open, not specifically an Onshape tutorial, but I guess it is, but also more a, sorry about touching the microphone. I'm still getting accustomed to this setup, but more of a, how does the thought process work with cats? Sort of like the fidget spinner video that I made, which I'm not very proud of. But yeah, same idea, making practical stuff. Yes, Litzing, Lulzbot, mini extruders. So okay, let's start out with Onshape. Let's start with the tool we're using today. It is somewhat similar to Fusion 360. It's not quite as powerful, I believe, but it's got everything that I need, so I like using Onshape a lot. The one limitation you have with the free Onshape account, it is free for you to use. You can use all the tools in there. You can use, all the plugins, all the features. But the one limitation is every design you create is public, and it says right up here, your free subscription allows you to only edit public documents. So every document you create is automatically, I don't think it's searchable, but anyone who has the link can view your documents. That's like the one limitation there. But for me personally, the stuff I design isn't like stuff that you'd need an NDA to sign for. It's useful designs that I make for myself, like a foot for an ironing board right there. The Halloween parts, Lulzbot mini extruders from Stephanie, GoPro adapters for a cheap LED lamp, just, simple stuff that I design and don't really care about who else is printing them. So which version of Onshape am I using? The one in the browser. Onshape is always, always updated. So Onshape does run in your browser exclusively. So let's open up this cable clamp design that I already started working on. This is literally running in Chrome. This is all it is. It's your CAD interface. You get something that looks sort of like a mix of Fusion, so the AutoCAD tools with the queue up here, and SolidWorks. It is from the guys that made SolidWorks originally, so you might find a few similarities, but I think it has, most of the stuff that people need, and I'm completely happy with it. But yeah, again, not specific to Onshape today, but more of a CAD thought process thing. I hope, and I'd love to see your input on what sort of management stuff you want to see. So the title image, if you looked at that, if that was what got you to click the stream, that's right down there. So I'm at my workstation, essentially, keyboard, mouse, screen, microphone on an arm, and that's the wires that are, my feet are in them right now. So I do want to clean that up. So it is a bit of a a project that I can use as well. And yeah, let's get into it. So yeah, Win 7 compatibility mode. I did have a few issues starting OBS Studio here on this computer. So let's create a new document. So feature script. Yes, that is awesome. Cable management. And what I believe how this works. So if you look at the URL up here, it has this long cryptic identifier up here. If you copy paste this as an Onshape user, if you're registered, you can open up this document. That's how I believe it works. But you can set up an extra step. You can say share. All Onshape users can view. That's the default. But you can also make a link like Dropbox or Google Drive or whatever. This link right here, I'm going to copy paste that. Copy to clipboard. Well, there's a button for that. I'm going to copy. Ooh, chat overlay is not working. Thanks for the hint. I totally forgot about that. But yeah, I am going to copy paste this guy into the video description. And the way this works essentially, so if you refresh the page, or it might refresh on its own, but yeah, the way this works right now, if you open up the link that is in the video description right now, it is going to take you to a snapshot of what I have on my screen right now. So it is going to, copy the design essentially and show it to you in that state. As I make changes, it's not going to update for you. You will need to press F5 or refresh the page to see, all the updates, new parts down here, new assemblies, changes, etc. And that is one limitation. If I actually invite people, which you can do as well, so you can invite individuals and say can edit, can view, etc. They can collaborate on the same design. They can design on the exact same part that you are working on right now, and change parameters, change features, etc. And that's sort of like Google Docs works, where you have multiple people working on the same document at the same time. And yes, it is parametric. You have the variable up here that you can name, that you can assign a value to, and you can use that in any feature, in any any process down the road. So let's see. Let's start with a very, very simple one. So we're going to rename that and just call it a cable clip. I did create a file like this before in SolidWorks, and published it on Thingiverse. And we're just going to recreate that, sort of. Let's see. In public cable management. It's BAME Maximus. I would disagree with you. It is not a more featured Tinkercad. It is a full-on CAD tool. So it is essentially, I'd see it as a replacement for SolidWorks, etc. I would, for me, it replaces any other CAD tool there is. So this is all I use for all my designs, because it has all the features that I need, at least for now. So it all starts with a sketch. It starts with a very classic, sketch-based design process. You could make this parametric. You could assign a variable and use that, but you can always go back and change these variables down the road and change your sketch, and the entire part will update if you design it correctly. This is going to be the cable or the wire where it's going to be clipped down. Cable, I guess. We could just create a second circle like that. But we can also create an offset and say, okay, we are going to use a wall thickness of, let's say 2 millimeters right there. There's our dimension. If I can grab it, there we go. 2 millimeters, that is going to be the thickness of this ring that's going to clip around the cable. And let's see. So it has this snap functionality where if you just hover your mouse, it's going to show you the constraints that it's going to put on those new features. So yeah, this is going to be right there, tangential to the circle. So this would be tangential to this circle if you click right there, and you don't have to add that constraint, right? Like right here, this is already coinciding with the circle and vertical to the center point of these circles. And yeah, I guess what we need right now is this feature right here, and this should be vertical. So Onshape doesn't really have that complex of a menu. It doesn't have those toolbars up there where it is super fully featured in every way, and you can click through them. If you've ever used SolidWorks, it has these massive bars up there that you can just cycle through. Onshape only shows you what you need. So if you're in sketch mode, it shows you the constraints you can add. It shows you your sketch features. It shows you your basic sketch shapes up here. That's just what you need. It doesn't show you like the surface design tools it has. It just shows you what you need, which I like. Let's just base everything off of the center point right here. So the idea is this is going to clip the cable right there, and then there's going to be a screw down the side. Let's make that 15. That should be big enough. And let's actually, why is this one not constrained? I guess it doesn't have the horizontal one. Here we go. And yeah, this one is going to clip right there. So next up, this is, so we at this point we could just select this area. I guess we want to cut this off as well. This area, and we'd have our part essentially. We can also trim off the excess here. We can just take the trim tool and say, okay, this thing we don't need, this, and this. And that would work as well. And now we just have a single, what is this area that we can select, and yeah, just extrude that. And that is going to be what we're going to do. So basic extrude, rotate is with the middle mouse button as in any other tool, cat tool. Move the camera is with control and middle mouse button. I realize I should have put a keyboard overlay on the screen somewhere. And we can just say blind, one direction. I like to do symmetric. So it's going to be, let's re-enable these planes. So it is going to be centered in the, or around the origin. And let's just make this guy 8mm wide. Here we go. That is a basic cable clip for an 8mm wide cable. I shouldn't have it hit escape. 8 symmetric, go. Now what we need is a screw hole. You could either, draw a circle up here, just slice through this part, or you can use what they have as a, where is it, right here, hole. This essentially gives you anything. So through holes, blind holes, tapped holes, anything you could ever want, but you need a single point on the surface, which we are going to create. So because we want to center this on this bottom surface, but we want the countersink on the top, we're just going to switch this to shaded without edges. No, hidden edges visible. There we go. So now if you look at it from the top, from this area, from this direction, we can see the bottom geometry down here. So select that surface, sketch, and let's get over here, back. So this is the bottom area right here, line right across here, and we will need to select this point down here and this one. And because they are on the same, if the sketch is two-dimensional, all the sketch sees is this, but because we have these two parts in three-dimensional space selected, they are going to line up perpendicular to the sketch. So if we say coinciding, this guy is now stuck over this corner permanently. Are we still in the sketch? Yes, we are. Deselect. So this guy is going to be for construction, because that is only going to be a helper line. And we can align our center point right on this line. And now this thing is going to be centered all throughout this part. Peek at chat. Yeah, Fabauti saying the i3 was designed in OpenSCAD, and OpenSCAD is the best CAD. It's a CAD for programmers. If you like that style, maybe that's for you. I'm not a huge fan of blind through. I'm not a huge fan of the OpenSCAD way of thinking. I don't like that a lot, just having to write down your entire features. It is very clear, it is very structured, but I just like working graphically. So let's see, simple counter sync, and we get this countersink up here. And this is going to take it's not going to take an M screw. It's not going to take a, metric screw, but it's going to take a 3mm wood screw or anything like that. So I guess M4 would be sufficient. The counterbore is pretty large, but we're not going to worry about that. It does cut off a tiny bit off the sides here, so that's fine. Let's fix the, oh crap, studio mode. Give me 1 second. I'm gonna fix the chat because chat is maybe not that important for not that important for you guys watching live, but it is going to be important for people watching the recording. So here we go. And there's our chat overlay. Great. SketchUp is for sketching. Yeah, SketchUp sucks. Especially like the STL export. That is horrible. Shaded. Okay, there is our first part. Maybe add a few. So the idea is it's going to be printed with this surface laying down on the bed. I guess, well, ZX is up here. So this surface is going to be laying down flat against the bed. And obviously overhangs, etc. The only thing is this hole, and maybe we have a 45-degree overhang back here. That's not too bad. That is printable. Let's make this thing a bit nicer. Add a few, what are these called? Fillets. 1, 2. Okay, this is too large. Let's set it down to 2. Now, one thing, let's just add these and discuss why they are bad. So here we go. This is going to be printed laying down with this surface again. The thing is, if you look at these fillets, this one up here, this one is fine. This is not an overhang at all. However, this one down here, this creates a basically vertical overhang right down there. So this is the printer's bed right there, and right here you are starting out with an extreme overhang. So this thing is going to curl inwards, and it's going to create a very nasty shape in here. I don't like that. It's not a great thing to do for 3D printing. However, what you can do, delete that feature, you can just use a chamfer on this edge and on this edge. Maybe not 5mm, let's stick with 2. And that sort of does make it nicer. And if you don't like the super edgy look, you can put a fillet on this and on this guy. And it's going to round it over a bit more nicely. All right, there's our first part. You can download this if you've got the document open in your browser. You can download this with an Onshape account. You do need an Onshape account to be able to export, copy, edit files. You can clone this design. You can work on it on your own and modify it to your heart's content. But for now, that's gonna be this one. Very simple cable clip. Again, the idea is you have a screw, you have a cable right there. This gets screwed down into a wooden piece, wherever, and clamps a cable down right there. Now, let me show you one more cool thing. So again, we said if you go back and edit this sketch, and you can just double click on any surface or feature, and it's going to open up the sketch that created that feature. Like we have this 2mm wall thickness right here, and we also have this 8, come on. Okay, you do have to double click it again. We do have this 8mm diameter in the center here. So if we said we need a bigger clip, we're gonna set it to 10. It's gonna scale everything else accordingly. We hit OK, and we have a larger clip. Going back into sketches is not the nicest thing to do. It's still possible. It's still better than not having the option. Like even if you say we need a small one for a 5mm clip, same thing. Updates everything. You have the new design right there. Let's show you variables real quick. So this is cable diameter, and we're gonna give it a 8. That's 8mm, obviously. Why is this red? Hoping this works. We need it right up here. What? Did not. Must be okay. So we can't have a space in here. Sorry. Cable diameter. Perfect. We did pull it up to the very first entry of the feature tree. So we can say, okay, generate this document only down to this feature. So right now we only have the variable, generated. We have the sketch generated. And from that sketch, it's going to create the extrude, etc., etc. So every time it shows you this model, every time it creates this model, it's just going to work from top to bottom in this feature tree. So it's creating the variable first, sketch, extrude, etc., etc. So if you had the variable at the very back, you wouldn't be able to use it in the sketch up here, because when this sketch is created, this variable does not exist yet. So these need to be at the very front of your documents, or at least before you use them in any sketch. So this is called cable diameter. So that is a hashtag, I guess, cable diameter in today's world. Open up the sketch again and just call that hashtag cable diameter. Boom, and it automatically plopped that variable in there. So this is 8 millimeters now. And what we can do now is just edit this variable, say, okay, now we want to do 3, enter, boom. And we have this with a 3 millimeter size. This is sort of similar to what you'd see in OpenSCAD correctly. That is pretty much what you can do in any parametric CAD tool. OpenSCAD is one of them. In SolidWorks, it's a bit different. You have like a variable list. I don't know exactly how it works in Fusion 360, but it is pretty much the same. Jan Medina is saying the link is not updating the design. You do have to hit F5. It does not auto update, so it's not a live update yet, unfortunately. Cool. That's the first one down. Actually, So if you have an Onshape account, this is not sponsored by Onshape or anything. I am not sponsored by Onshape, but I just like the tool. So if you want to grab this design, if you want to modify it, if you want to print it, you do need an Onshape account. They're free, obviously, and then you can get down here and say export. So let's say we want to print this. File name is already correct. Format STL, that's what we need for variable. Yeah, whatever. STL binary, yes, binary is what we want. That saves a bit of space. Units are millimeter for 3D printing everywhere. Resolution custom, let's say medium. Download, or you can store it in Onshape itself, so you have it stored with your document, but I'm just going to say download. Okay, cable clip, it opens up as a zip. And let's just open it up in NetFab real quick. And here we go. There's our part. And dimensions are correct because this is millimeters. There's our part, already correctly oriented for 3D printing, because we said this surface is going to be facing down. Yeah, that's your workflow right there. Variable. Whatever, I'm German. I don't care about your pronunciations. Okay, very basic design, a lot of screw holes, but yeah, everything is adaptable. We could go full ham and add more variables. Shit, that sounds worse. We could add more of these, and can we copy these? No. And just make everything parametric. We could make the thickness parametric. We could make anything parametric, but you can always go back into the features themselves and say, okay, this thing is going to be 12 millimeters thick now. Same for that, and it just auto updates the rest. I'm making it look easy probably right now, but it requires a lot of practice to set up a part to where it updates when you modify the very first sketch. If you like, let's put this back to 8. Like this thing I did. Finding the center of this part using the edge down here, the corner right down there, for this sketch right here. That is one of those tricks that you just need to learn over time, that you just need to know that finding this center is something that you need to do in a way where it's robust. If like the dimensions change, if this length changes, you can't just have a fixed length from this part to this part. That would be the easiest one to do, sure, but it also throws off this center finding sketch, or if you don't have a sketch, if you just put a point on there, that's just going to shift all over the place and break your part, and that's not something you want to happen. Like what we had with the variety shit with this part being red, and that's exactly, you know, when Onshape or your CAD tool says, okay, I cannot regenerate. That's what it's called when it's rebuilding the part. I can't regenerate this part right now with what you specified, like when this hole would be outside the solid, or if it would be somewhere else, that would break it. It's just, you know, you just need to learn it over time. And again, it's free. Just, yeah, try it out. Right, this one. So the cool thing about Onshape is the way they handle documents, the way they handle assembly documents. So okay, let's jump back into the Onshape main menu. So right here we have the cable management. Are they calling it documents? Yes, they are calling it documents. This is a document. A document can hold a lot of things. So the export option we had with the STL, that would just create another tab right here. A document can hold parts. This is a part. A document can hold assembly, which consists of more parts, or many parts, or a single one even. An assembly won't let you edit parts themselves, but it's like a well, it pulls in the parts from your parts section right there, from your parts tabs, and displays them. You can mate them, you can arrange them, you can, you know, make them fit together, whatever. And yeah, you can also, let's check this out, add application. What did I use? I use the 3DX certified models a lot. So if you've used SolidWorks before, you will be familiar with the toolbox, unless you're using the student version. That one does not have the toolbox, but this is what they call an app. These are essentially plugins for Onshape, and you can see it's another tab, it's another, you know, application that's living in this document. And for example, you can just, you know, grab a bolt from it. This is also something that is now part of this document. Let's just grab a 912. No results found. Cool. Standards-based hardware. Should we search again? No, this. Okay, whatever. Screws. There's our 910 socket cap screw. Socket cap, and we're doing. Okay, I ended up in the NC tab. Whatever. But this is also part of a document. So, for example, you could generate new parts from this app. I could add Kirimoto, which is a CAM program to pre-process for milling, for example, or I think it even does 3D printing. I can add simulations, you can add visualizers, which is a render program. That is all part of a document. And the cool thing is, because a document is more like a folder, you can just add another document, or another part studio. So another part to your document, and it's all part of that same document. So let's create another cable management thing. WE saying, hey guys, is anybody visiting the Make Munich next weekend? I am. And if you're in the area, you should definitely. It's a great maker fair, and they're growing every year. It's awesome. It's an hour from me. I will be there both days probably. If you're there, say hello. Check out the exhibitors. It's going to be a great maker fair. Nerfer59 is asking, why is this not on my live channel? Because this is probably so. Okay, let's can I show you? Well, right up here, this is like the info bar thing that's scrolling through, and it does have a link to the second live channel too, which is intended for less polished, less set up, less, how do I put this, managed, highly polished streams. So just the casual stuff like, I'm working on my printer now, come watch. That's what that second channel is for. This one is for streams that I put effort into. So right now I'm sweating. I am, working hard essentially. This is what this channel is going to be for forever. Same with the stream. So I do want to stream onto this one with stuff that I put effort into. The other one is just going to be the low quality, hey, come hang out with me channel essentially. I'm hoping that clarifies that up. Cool. Why are people talking about Blender? And my screen just turned off. No, it's back. Cool. Let's make another one. Let's do a bit more parametric stuff. So, Ink, Windows, Sketchpad. Actually, I did a similar thing in the how to Windows 10. I did a similar thing in the fidget spinner stream essentially, which was a very similar one to this one, and my graphics tablet is not working. The way I like to start out is just with a basic sketch. Sometimes it just lives in my head, which is okay. But I'm hoping this is the crap, that was the wrong button. There we go. Sometimes that sketch, that idea just lives in my head, which is okay for a lot of stuff. But sometimes I just need to sketch it out, for example, for you guys to visualize it. So how do these work? I've not used this too much before. So what I want to create next is something where you have like a little... I am horrible at drawing. I know I am an engineer. I am not someone who draws or should be drawing. And if I'm drawing, I'm going to be using CAD for it. So essentially, these grooves for cables that you can just lay the cables into. And on the side, it's going to be a screw hole again. Right there. So that's going to be a counter board screw hole. I know this isn't even a proper engineering sketch, but whatever. And down here, it's going to have little hidden channels for a zip tie. So if you put a cable into this guy, let's say there's a cable. Yay. Also, this graphics tablet isn't really precise. So yeah, there's a cable, and the idea is that you're just going to slot a zip tie through this thing, zip tie this up, and it's going to get tightened down. You get the idea. And so we're going to have two parametric parts to this guy. So we're going to have a diameter, a cable diameter again, and we're going to have the number of grooves, cable mount points, essentially. 1, 2, 3. Wow, these distances are not equidistant. That's, yeah. Let's close this thing. We do not need to stare at that. But you can make that parametric. You can do this with a variable and just make it configurable, make it fit your printer's build volume, essentially. Questions from chat asking about the little spot more extruder. I've not tried those yet, unfortunately. Why not turn it around? What? Turn what around? So you have the cables on the inside? Oh, I see what you mean. So you'd have your input from chat. The Billy777 is saying essentially, if we have, let's pick this guy, if we have the surface we're mounting it to right here, and we screw this down like this, it's clamping the cables in here. The problem I have with that, it wouldn't need zip ties, obviously. The problem I'm having with that, it's hard to take out and insert cables, and when you screw this down, you will need to arrange every single one of these perfectly. And if you have cables of a different diameter, it's not going to clamp everyone or every cable equally well. So it would be more of a cable carrier, I guess. This is just then, open up the zip ties. Zip ties are free, essentially. They're so cheap. Cut this thing open, insert a new zip tie, zip it down, and this thing is going to be solid. So yeah, that's my idea for now. Of course, you can always flip it around. You can always use it the other way. So this thing is going to get screwed down, permanently to the table. Or table. In this case, yes, it is for my table. It is for my desk. It's going to be wire management living on the underside of it. So that's that. Never leave your graphics tablet pen on the tablet itself. It's going to throw off your mouse. Velcro instead of zip ties? Could work. Could work. Let's make that parametric, because I do have, let's see if I can find them real quick. Yes, there is one. Ooh, it has just in them. So I do have these zip tie Velcro loops. They are incredibly cheap. You can get like, I don't know, 10 for $2 on eBay. These things are great. The problem is they're only zip tie Velcro loops. They're nothing else. They're just the loops themselves. So whenever you do anything with them, that they're great for bundling wires, but they don't really mount wires to anything. So the idea is use these, slot them into the slot that is supposed to be for the zip ties. Make that slot a bit wider, obviously, because this guy is wider than a zip tie, and use that. And I think we can make that parametric. Let's jump back. Let's see what parameters we're going to need. So again, thought process of making a design. What I find myself doing quite often is I'm going to design a part in CAD, have a full solid model, and end up with a model that looks like what I want, that functions what I want, but the CAD model is going to be a mess. It's going to be horrible. So at that point, I usually just start over from scratch and redesign the entire thing and make it properly, like have it parametric, have it well designed, have it, well done. So let's see, my handwriting, can I actually type in here? No, I cannot. Great job, Microsoft. So parameters. Parameters. We're going to have number of cables. We're going to have cable dia. This actually looks better than my usual handwriting. I'm proud. We're going to have the zip tie width for Velcro and depth. T's there, yeah. So 1, 2, 3, 4. I think that should be pretty much it. Number of cables, cable diameter. Yeah, perfect. What do I think of? Yeah, Javiv Martinez is asking what do I think of other CAD programs that have educational versions and are legal to use for open source stuff. So for example, the Fusion 360 licensing does have a similar licensing model where you can have, is this correct? Yeah. Where you can have, the tool for free, you get all the features, and you use it for open source, educational, hobby, even startup work, basically everything. And yeah, I kind of like the way Fusion 360 has it set up. However, what I've seen with that was wrong. What I've seen with SolidWorks while I was studying is they give you this super microphone. Sorry, they give you this super stripped down version of SolidWorks that does some things. They get you hooked. They show you, okay, this is a great tool, and I honestly I love SolidWorks and it's awesome. But they give you this tool that is like, free for you as a student. It strips it down so much that you can't use it for anything else than maybe a few student projects. It might have STL export at this point, but when I was using it, it did not have it. And as soon as you graduate, essentially, as soon as you graduate, all those features go away. The educational version disappears for you. You can't use it. They're only like licensed for a year, and as soon as that runs out, it just stops working. And SolidWorks is expensive. It is a ridiculously expensive tool, and you do have to update it every year. So I think like the base license is 20K, 10 to 20K for the base license. If you get the fully decked out version, it goes up to like 80K. plus support contracts, etc., and plus VAT probably. So yeah, you're not going to be using that for any private project. And even if you use it for a professional project, it's going to cost you a bunch. Why did I start with the sketch? Let's focus. Okay. Cable diameter 0. Well, let's not make this 0. Let's make this 8. New one. Number of cables. There is probably a better standardized way of naming these. But I'm just naming these how they work for me. Number of cables, we had zip tie width, which I guess I should have brought calipers. I didn't expect this to get this deep. So this guy is it's gonna fit in a 20 millimeter slot. So let's just stick with that. 20 and zip tie height. So this is gonna be a printed overhang. No, it's actually not gonna be. Okay, well, then we can set this to close to the real thing, which is I guess it's gonna fit in a 3 millimeter slot. Yeah, Farbout is asking, what are you guys printing now? That would be interesting. Set of planetary gears. I'm hoping that's not just decorative ones. I'm hoping those are ones that are actually gonna seat on a motor and yeah, be useful in some way. So sketch, here we go. Top plane. P to hide the planes, the AutoCAD style planes. Let's start over. So I will need to mirror this at some point, but for now that's okay. So there's our first dimension. So D for dimension. We just click the little icon up here. And that is cable diameter. There's our 8. I guess we could add another parameter for, I'm just gonna call it parameters for now. I know how to pronounce that. We could add another parameter for thickness, but I think I'm just gonna leave that at a fixed 2 millimeters for now. So offset again. Offset could not be created at this distance. What? That's probably gonna be -2. Here we go. So if it creates the offset in the wrong direction, so like if we set 2, it's going to create it on the inside. In this case, -2 just creates it on the outside. So that's going to be a 2 millimeter thick wall. New ramp for your home-built pinball machine currently. That sounds awesome. That sounds pretty epic. I mean, pinball machines, they are complex beasts. Holy crap, man. So this is going to be the slot for zip tie height. Tie height. And that automatically grabs those 3 millimeters. To use an array of multiple cable diameters. I'm sorry, I'm not catching up to chat too well because I am focused on drawing and doing this stuff. I do have chat open, but it's scrolling by really fast, and I don't want to stop and look at chat. An array of multiple cable diameters. You can clone the part and add that yourself. It should be, yeah, it should be possible to modify that. Okay, do we actually need any wall thickness down here? I don't think so. We can just let because it is going to be sitting words. It is going to be sitting against a surface right here. So this is essentially our surface down here. If we drag this guy down, this is just going to be open, which is okay. But I'm still gonna give it like a millimeter or something. So this is constrained to horizontal. I am just gonna give it a millimeter of depth right there to just guide that thing around in case the surface down here isn't really great. So Yeah. Let's see, and this thing is just going to be horizontal right there. Okay. So this is one half of the arrangement. Of course, it probably doesn't look like too much yet. Let's add a center line, and I think C is circle. What is construction? Q, construction. Okay, whatever. Construction line, because this is not going to be part of the geometry. And let's just mirror these two to the other side. And this works similar to SolidWorks. If you have a construction line and other entities that are not for construction selected, it's just going to pop those over to the other side. So now this stuff is mirrored, and this is essentially one holder. We don't need all this crap up here, actually. So bye-bye, bye-bye, bye-bye. And it keeps all the dimensions because these are still attached to the geometry down here. So whoop. Can I drag this? Oh. Okay, it doesn't look like I can drag them down here, but we still know where these belong. So 3, 2, there we go. And we also don't need this seat up here. And I am going to create a bit of yeah, mods can still say nasty words, but other people can't. It was getting on my nerves. It's not a political thing or company politics thing. It's just it was just getting on my nerves. Same with Core XY. So yeah, I am actually going to create different geometries from this one sketch. How am I going to spin this? I think I'm just going to pattern the. I am going to pattern the part. I'm not going to pattern the sketch because that would be crazy to create a part, an extrusion from that, because you'd have to select all the correct areas. So let's just create one of these cable seats. Let's pull this guy right here and give it like 1 millimeter. Let's make these vertical. That's V, I believe. Yes. And just say this little tab back here is going to be a single millimeter to the next one. That's this area right here. This is going to be where the Velcro or whatever slots in, where zip tie slots in and wraps around the cable. Cable's going to drop in up here. And yeah, this is 1 unit. So let's close this up and generate our single cable seat. Where we driver is asking, would I buy another MK2? For the record, I didn't buy a Mark II or Mark IIs in this case. They were provided to me by Prusa. I did not purchase or pay for those. Would I still recommend it with other printers coming out? Yes, absolutely. It is still a great machine. If it is what you're going for, if you are going for that maker style printer, if it is single color, maybe okay. The dual extrusion kits are shipping right now, so you can get dual color. But yeah, still a great printer. Still very happy with the ones I have. All right. Now this is going to be up here. Obviously, that's where the cable is going to sit. We still need end plates. We are going to add those in a second. So depth, also we can use the parameter of zip tie width in this case. I believe so. I've never tried this actually, but this should work. Yes. Okay, so it automatically grabbed those 20 millimeters, and now we have this geometry right here. Okay, we do not have end plates yet. We still need those. So let's go back into the sketch. Grab the... Ooh. How do we do this? I think we should be able to do it with these areas right here and add another extrude. And in this case, let's see if this works. Up to face, and that's going to be this face. and we're going to start at an offset. Okay, this is where Onshape sort of falls apart. SolidWorks is awesome at this. This does not look like what I want. SolidWorks is awesome at this, just saying, okay, I want to go from this point to this other point. Can I just say up to next? Okay, but that doesn't. Okay, let's do blind. Let's do the math. So blind, and we can add a second end position. So the thing I didn't realize for a while with Onshape is it does have most of the features you're used to from other CAD packages. You just need to work to get them. They do work a bit different. So extrude everything, then cut away in the middle. That would also work. Yes. Let's try and get this thing running. So blind is just from where our sketch is to an end position. So as I change this length, it changes the depth that we're using. So theoretically, we would have, yeah, we can do this. We can do this. We're gonna do zip tie width. I have to put this in brackets. But divided by 2 plus a thickness of 2 millimeters. Here we go. Now our end position is correct. This is, adding a 2 millimeter thick end plate, and we're going to add a second end position. Let's see. So there's our second one. And if this is, between the sketch and your end position, it's actually going to cut away from your geometry. So if right up here we say zip tie width by 2, it's going to create an exact end cap right here. And one thing I want to point out is the new add, remove, intersect option up here. SolidWorks has, what is it, cut, extrude, whatever. It's got the positive and negative type of every feature. So essentially you can you have your own features for cutting, and you have your for taking away material, and you have a different feature for adding material. In Onshape and in the Autodesk tools as well, it is one feature in one tool, so you can create a new body. You can add to your existing bodies, or you can remove, intersect, etc. You can do those Boolean operations in the same tool, in the same feature. So for example, if you're saying new, let's just use that. We now have 3 bodies, 3 parts. You can see these down here. We have 1, 2, 3. I don't know where it's selecting those. 1, 2, whatever. 1, that's the outer shell, the bottom one. We have part 2, that's the upper shell with the cable seats. And we have the third one, which is the end plate. And all those are individual parts, individual bodies. So if you'd print them, your slicer would see them as individual parts. You can combine them, which we're going to do in a second. But the cool thing is, because we have these option of new add, for example, if you're saying add merge with all, it would just create a single body. Do we actually want that for now? It's not. Well, let's do it differently. Let's do it with the actual individual bodies. So what I'm going to do is grab this part, and I'm going to mirror it to, let's view those, to the opposite side. There we go. And now we have our nice cable shell, our nice cable clip. By the way, is this turning, scrolling, is that, getting you guys dizzy? I do it a lot just to keep an overview of the part, but it might make you guys sick or something. Just let me know in chat. I will try to keep an eye on that. So yeah, there is our parametric single cable seat. Of course, these are still 1, 2, 3. Now it's 4 parts. It's 4 individual bodies. So what we can do is we can Boolean these, essentially combine. So union, subtract. So if you have like a cutting tool and want to remove that, if you want to make an impression on a surface and have like some text that you extruded or whatever, you can do that. Intersect, so only what physically intersects remains. But in this case, we just want union, all of these. done, and now we have a single part. Cool, that was harder than I thought it would be. But this is exactly what I wanted. So we can still change these parameters. We can still say this is going to be a 5mm wide zip tie, and it's changing the entire part to be smaller and to accommodate for that. But let's stick with the Velcro straps. Okay, cable diameter, all parametric. So yeah, if we change the cable diameter, this entire thing is going to get wider. So if you say we're going to have a really thick one, 20, yeah, this entire part gets wider, and it also gets deeper. It also gets taller. But let's undo that regular wire diameter for now. No people are getting blocked in chat. Nightbot is temporarily muting them. All right, so this is one. Of course, we need a few more, and let's multiply these first, and then add the end parts to actually screw them down. So this is a similar feature to the mirror. We're just going to do a linear pattern. Oh gosh. Okay, let's go through this step by step. Entities, direction, we can just use this edge right here. Where's our z-axis? XYZ. Actually, I do want to do this in the other direction. Instance count, that is number of cables. Cool, now we have 10 of these. But the problem is the distance that we need, we can't really, if you do centered, it just goes both, it goes both ways. Okay. Yeah, we still don't have the distance that we actually need between these parts, or between each instance. So from this corner to this corner, it's 25mm right now, because this pattern has this 25mm distance. So yeah, let's figure this out. And I think we can actually go into the, no, it's actually relatively simple math. So if you look at the width of this part, can we dimension in here? We can always grab a sketch. So the width of these parts right now is, this is going to turn gray, I hope, 20. Yeah, 20, because this isn't a dimension we can change, obviously, because this is directly taken off of the width of this part. So 20mm it is. How does that combine? So it's the cable diameter, it is the thickness right here between the zip tie, Velcro strap, well, and the cable, so that's twice. Then we have the width, or depth, width, height. Okay, height of these parts twice, and we have that millimeter gap. So we have a fixed width of 1, 2, 4, 6 millimeters, plus cable diameter, plus twice the zip tie height. Let's do that. So let's do cable diameter plus 2 times, I think it does like math, basic math rules. Measure, ooh, custom feature called measure length. Mikhail, now if you can actually point me to where that is, where that feature is, because can we just say, nope, show dimension? No, that's just this one. Okay, measure length, where is that? Just by cheap industrial cable channels. Dude, you're missing the point. You're missing the point. It's not about, it's about CAD. It's about making stuff and having this stuff available to you. But yeah. Linear pattern. Let's go back to this. So fixed 6 plus cable diameter plus button on the right. Ooh, okay. Search. Thank you for that, Michael. Measure. Holy crap, Onshape is getting better by the length. V2 start. Okay, so that is, I guess, the newest one. Can just drag this guy up. Was added to the toolbar. Awesome. Measure length. Just gonna measure this guy. Length. Name. Single width. Come on, width. Single width. Holy crap, this is awesome. So let's move this up here because this feature needs it. This feature needs that parameter. Measure length name. Okay. And if that is correct, this should just work with single width. Holy crap, that is awesome. How will these manage cables? It's not about the cable management, it's about the CAD. Cool, this one we don't need. And this point right here, in case you're wondering, because I'm wondering right now, this is our origin. This is where the entire thing is centered. Slid inside the model, sketch the circle and extrude some length. You would be done in 10 seconds. What? Yeah, but I'm explaining what I'm doing right now, so doesn't apply. Union all of these. Done. There is our first bracket. Because everyone is complaining about Nightbot is too harsh. Let's see if I can sign into Nightbot and see what his blacklist is. Because I do have a fairly strict blacklist, block list, mute list on Nightbot because I mean it's live chat. People are gonna be stupid. So spam protection, blacklist words, phrases, options. I'm not gonna disable the entire thing. Let's get these out of here. I think that should be it. They actually have... Here, let's cool. That should be it. So yeah, Nightbot should be a bit less aggressive. But thank you for the feedback. It is much appreciated. Right, let's add some tabs on the end. So again, this is the coolness of parametric design. You hit the wrong button and nothing happens. You change this guy to 5 and now it's just a 5 cable long unit. I like that. I like that. And if we sketch this right, let's see, how do I sketch this? So I want to create some tabs on the end that just have some, so it's going to be printed in this orientation. I just want to create some tabs that have a screw hole in there. I do need to have, first of all, it does need to be dependent on the height of this part, because if I create a screw hole and then lower the width of these, then that might crash the screw hole. And also it needs to be symmetrical, but I think I can figure that out. Yeah, I can definitely figure that out. Put the center one in the middle of the part. What? Right, let's sketch some connectors. Let's actually, which side to use? I guess this one. And so we're saying again, he ordered a spool of dust filament PETG. Awesome. Yeah, it's the one company. It's one of the companies that I don't have any affiliation, as in affiliate links with. So yeah, it's just filament that I like. All right, let's create our center mirror line first. That was Q for construction. Yes, so this one we're not going to use. This is just going to be the one where we mirror everything we do over here onto the other one. I guess we could also do that differently, but now let's show you a few different ways to do things. So what I'm worried about right now is that the height of this entire thing might change down the road. So I am not going to center our screw hole. I am going to offset it from the bottom and create a feature or a sketch part that just gives it a fixed height. So let's see. Does this CAD support assemblies? Yes, it does. Of course it does. Why wouldn't it? I don't even have to close this. Maker's Muse has more subs. Cool. Congrats. All right, that's our basic premise right here. So very cool. I'm not going to use the whole feature in this case. I am going to, leave this with a round sketch part right here. So let's see, fixed width. Give it 4 millimeters, something. Yes, this could all be parametric, ideally. No, actually, let's make this a consistent. I guess I could also be using a square for this, but let's make this a consistent width. Oh, coincidence constraint cannot be applied. So this one is going to be tangential, and this one is going to be tangential as well in this circle, just for construction. So now this guy is centered to the left and right. And I guess we can just pull this guy down and create these mounting tabs that are independent of how tall this entire thing is going to end up. Here we go. Sweet. Who's Tom's Hardware? That's that other media channel. That's not me. They stole the name. No, okay, they were there first. Okay, mirror. Let's do the mirror feature like it's intended to be used. Select the mirror line. This guy. Select entities to be mirrored. These guys. And now it's mirrored. And we can just extrude this entire area and this. Come on. This area and this area. And it's always going to be attached to the ends right there. And depth, because I could just have it to this depth right here, just to make it flush with the top surface. But again, the problem is if anything changes here, that height is also going to change. Let's just make that a fixed 5 millimeters. Yeah, that's fine. And add, which means it's going to fuse it to the rest of the part immediately. So still parametric, still, again, the entire thing with mirroring this and creating center lines and making sure this sketch is not like constrained to any of the other dimensions in this part is could the mounting tabs be placed on the center of the width? Yeah, they could. Let's just finish this. So again, I can change this guy. Final. Is that a preview? 10. Oh. So 10, this guy is still on the end because our center line also shifted towards the center there. And if we change like the zip tie width to 2 millimeters, these mounting tabs are going to stay the same height, and they're just going to be independent of the rest of the model. They are going to be attached to the ends there, which is perfect, but they're not going to be trashed by any dimension changes right there. Okay, of course, from here on out, we can add. I never use the control middle mouse button to shift things around. From here on out, we can create a few features to make this thing look a bit better, like a chamfer right there and there. Like make it a 2mm one. The thing is though, if this, well, let's see how this turns out. So this chamfer right here, as we just saw a second ago, this part right here, this might be shorter than the tab. Let's see what happens to this chamfer right there. I'm thinking it might actually chamfer the other way. Zip tie width. Final rebuild. There we go. Perfect. So in this case, it just chamfers the other way, which is exactly what we wanted. Chamfer up, chamfer down. And because this is going to get countersink screws, we are also going to add a chamfer on the top right there. Maybe not that much, but like a 3mm one. Perfect. So I'm guessing at this point you are seeing how this part is supposed to be printed like this, so that we get these internal sections printed nicely. Can we do a cut section view? Yes. Section planes right there, and we can get you a section view right there. So again, people were questioning what the what this exact concept is. It's going to be printed this way up, just like you see it, and this groove right here is this groove right here is going to seat a Velcro strap or a zip tie or anything else right there, and this section up here is going to seat a cable, and that's just going to get held down by these parts. So let's cancel this section view, and this part is done as well. Of course, again, you could add parameters, etc. I don't think like I should drink my tea. I always forget that with these live streams. Peppermint, by the way. Cold peppermint. Ugh. But yeah, that's that. David Pato is asking, or saying, post a model for us. You can already download this thing. This thing is live. If you open up the link in the video description, you can download this. You need an Onshape account for this to download it, but you can view the model. You can play around with it, and if you have an Onshape account, you can clone this model right now and edit it and modify it yourself. You can. I need to version it to make it show up. What? So yeah, let's just move on here. So Onshape has versioning, like GitHub versioning. You say, okay, this state right here, everything I have right there is version 1. The base, lowercase, functional model, version 1, create. And everything I do from now on out, it goes into this, open, current, unversioned status. If you remove the roof off part, nope. If you make changes, you can always roll back to that version. You have an unlimited undo, I think, as well. But the versioning just gives you those snapshots. I don't know why this is taking so long. There we go. And Billy, so I know your name, but I still don't know how to pronounce it. It's way behind right now. I don't think the versioning actually updates it for people out there. You do have to refresh the browser occasionally, unless I actually invite you to the model so you can edit live. If you just open up the link, the URL in the video description, it gives you a snapshot when you open it of the part. When you actually refresh your browser, I think it should show you exactly what I am seeing right there. Let's organize my windows real quick. There is a lot of stuff going on. Cool. that is another cable organizer done. That's one that I'm going to be using a lot, probably more with the more with the sorry guys, let's forget what I just said. Yeah, this is done. I do want to create one more cable organizer thing. Yeah, that's the other thing. There are two parts in this design. They are both in the same document, but you can of course switch between them, and by default I think it opens to one of them, and you're not seeing the exact one that we have right now. So just for fun, I guess, let's try out the assembly, because someone was asking, hey, does Onshape have assemblies? And yes, it does. By default, it has this assembly one. Let's just show how that looks real quick. I am just going to create a quick cable, essentially dummy dimension. I know you can click somewhere in the sketch as you start, but I'm never know where exactly to click, and usually it goes wrong. Let's just say we have a cable dummy 80 millimeters long. Perfect. Okay, the way Onshape does assemblies, it uses these mating connectors between entities. So you can see this guy right here. This is like a hard point, essentially. This, and it creates a mating point in the center. These are essentially, click, come on, between sorry. Face of extrude. Let's start over here. Between entity there, and it creates the hard point, the mate connector in the center. I could have just also clicked on this. Boom, and now this will snap to another mate connector in another part. I could also just have, we can add some on the ends, right there, and these are just points where you can, confirm. These are just points where you can connect this exact part to other parts that also have mate connectors. If you don't have mate connectors, nothing's going to happen. The link is not working for you? What? On the link is not updated? Hold up. Onshape document C999, whatever. Let's open this up in Firefox. Empty? What? Loading workspace. Okay, I am not signed in, and I'm seeing the exact parts that I've got open in the other browser. If you do have it open, give it a refresh maybe, but it is definitely working. Okay, mate connectors. This guy has mate connectors. Mate connectors are part of the part, essentially, of your physical model. So for example, these stay with the part and are not a part of the assembly. Let's add another mate connector. Can I actually? Yeah, there we go. One right in the center, and if we mate this to the other one on the cable, it's going to snap into place right there. Rename 8mm cable dummy. Assembly 1. Insert. Let's insert this guy, and it's just going to add it to the origin. There's our mate connector in here. Let's add another part. Let's add the cable dummy. And I think we can we snap it in place? I don't think we can. But yeah, right now we have two parts in the same assembly that are just, loose. And you have all these different mates that basically just lock parts together in different ways. And does it have a tangent? Does it have a locked mate? I don't think, but can we do a slider? Maybe we can. Right there. And that just snapped into place. Can we slider this? Oh yes. Oh, this guy is also not locked in place. Fix. So now this guy slides. Cool, because it slides along the z-axis of these mate connectors. I'm just realizing it's too large. Why is this too large? Why is this too large? Did I not use 8mm for this? What? Oh, I used an 8mm radius. Cool. 4. That's smaller, and this also auto updates. So now we have this guy right in here. That's how it's supposed to work, and then a zip tie through these guys, obviously. Right, that is the assemblies. Let's do one more. I do want to make a snap lock, snap in place thingy with a living hinge. Let's rename this guy real quick so we know that this is the multi zip holder. Got it. So one more part, and let's pull up the sketchpad again. Raise that. Where's my pen? There's my pen. So basically, idea. Snap buckle right there. Well, I guess this is gonna curve down to accept a cable. Then living hinge right here. This obviously goes down like this. There's another screw hole in the very bottom here. Living hinge. I guess it doesn't need to be that long. Right there, and this goes over this snap. So like this. If you know what I mean, and whatever cable we clamp is going to seat in here. This thing is going to use a single screw, and it's going to snap in place. Hopefully, this part up here is going to flex, and we will have a. The part only has 11 features. It doesn't have any more than that. Yeah, this thing is going to snap in place and just seat in like that. We will need to see what material can make this living hinge work. I think a nylon would be pretty cool. But yeah. Let's see, top, and yeah, we do need to print this living hinge so that it aligns with the layers. Yeah, quick question from chat. Lucas Hartman is asking, is Onshape open source, or do I have to trust them to never lock me out? It is proprietary, it is browser-based, it is pretty much the opposite of open source. It is free, but not as in freedom. It is only free as in beer, with restrictions. It is also cloud server, etc. based. So if their servers go down, your parts are, well, inaccessible for the time being. You can export, let's just show you that real quick. You can export to most common files. You can, export. You can even export to SolidWorks. I think that is new, but you can pull your parts out in any format you want, or STL obviously. So it's not locked into Onshape that much. It gives you good export options. I would have to try that. Onshape, the SolidWorks one might even have features. We'll need to try that out. But yeah, it imports, exports pretty much all formats, and yeah, but it is still closed source, proprietary, etc., etc. So yeah, not open source, but then again, I find that a lot of the good tools are not open source, unfortunately. I wish they were, but that's just reality. Cable, clip, is it? It's another clip. Cable snap, I guess. So let's start out with the, no, let's not start out with the sketch. Let's start out with the parameters. So again, cable, I guess you could also set up a basic document and use the versioning and forking. Forking is up here, make versions and history. Make history, manage, I misread that. You could just make a base document and set all this stuff up once, and then just copy paste it. Diameter. 8 again. And I guess that's all we need for now. Yeah, width is going to be fixed. You could do that. Yeah, also Onshape works in... Cool. Onshape works in any browser. It is a bit slower in Firefox. It's not that well performing. It works really well in Chrome. So yeah, I use it in Chrome. I usually use Firefox for everything, but it is a lot slower in Firefox. So that's that. But it can also open up documents on your phone, on your iPad, on Android, Apple, whatever, anything that runs a decent web browser, and most devices do, unless you've got a Windows tablet or phone. But yeah, any modern browser does run Onshape. I think it does work on edge-based devices as well. Yeah. Right, let's start. Again, cable, center, and we are going to be cutting away everything we don't need in a second. And again, the cool thing is if you sign in with the same account on all those devices, you are getting the live update on everything. You are getting it on your phone, on your desktop, on your wherever you decide to use it, because it is live. It is browser based entirely, but I think you get pretty much the same with Fusion 360 as well. They do have a lot of cloud features as well. Buzzwords, cloud. This is just going to be, I think this is going to be a dual feature part, but it's going to be a very simple part. It's just going to be one sketch essentially. Let's do another offset right here. Let's do 1 millimeter. Construction again to get a consistent wall thickness. That is tangent T here again, and then up here as well. And the notch over here for the living hinge, we're gonna cut that out in a second. And I don't know, should we? Yeah, because I am thinking, should we actually print this in place, or should we actually have this in an open position? I guess the open position is a bit harder to design, so let's just stick with this and leave a tiny gap. Cool, shucks. 3D printing is asking, why am I not using Fusion 360? Fusion 360, why am I not using that? Guess this should be a bit larger. Why am I not using Autodesk Fusion 360? First of all, I've had horrible experiences with Autodesk and their reliability in the past. Some of them are fueled by what used to be, what is it, the photogrammetry? I can't remember its name. What is now Recap 360, I believe. What's the angle gonna be? Capture? The name escapes me at this moment, but that thing has been horribly reliable, but it had the Autodesk badge on it, and I feel like that was just horrible PR for Autodesk. Putting out a piece of software that was that buggy and that horrible, just, I don't know, it doesn't float well with me. The other thing is the Fusion 360, I think it was Capture, yeah. The Fusion 360 licensing model is a bit restrictive, to say, like the 100,000 euro revenue limit. It's all of a sudden the program goes away. It's one of those things like the SolidWorks student license. You can use it for a while. You can use it as long as the makers are happy to let you use it. But at one point, it just, they're just saying, nope, you're not getting it anymore. And I do prefer a model like what Onshape does, where you have like the same restrictions for everyone, where you're saying, okay, you can use the full program, it's fine, you can use it to whichever extent you want. there is this limitation where you have to make everything public, but that's it. That's never going away. So I do prefer that to having a situation where at some point, because I am not a legal entity, a separate legal entity with my company, with this channel, but it is a company. And, you know, if I'm saying, okay, I'm going to hire an employee, I'm going to grow the business, I'm going to do, you know, businessy things, and 100K of revenue is not a lot. It is, you know, one employee and it's over. And at that point, you know, Fusion 360 would just go away, it would just be poof, hey, you have to buy the license now. And for the amount that I use it for, it's just not worth it. Okay, so I hope that clarifies that. For a maker, probably it's a good choice, but for me, it's just a bit too restrictive. Onshape Enterprise version has the explode function. I don't want to blow stuff up. I'm not at that point yet. How do we play this geometry? So we have a 2mm notch right here. Dude, if you ask something serious or something valuable, then I might say your name, but not for nothing. If Onshape takes away the free version, will you consider migrating to Fusion 360? I'm probably not. I will probably look for something else. Someone has brought up FreeCAD a minute ago. To be honest, FreeCAD, it's free, it's open source. That is invaluable about any tool. But FreeCAD is also. I tried using it a few times. I tried using it at this distance. I don't want that distance. I tried using FreeCAD a few times, but every time I tried, it was just pain. It was pure pain to use. The same stuff that took me minutes in... Oh, it doesn't do point. The same stuff that took me minutes in any other CAD tool took me, you know, half an hour in FreeCAD. It might have been because it's because it's a tool that I hadn't used before, but so far I've not had that much of an issue getting into any CAD tool. Come on, why can't I offset these? I've not had that much of a learning curve with any CAD tool so far. Okay, here we go, 0.5. We're getting there. And then these as well with 0. I cannot type this in. -0.5 negative. Let's just select these and make these coincide. So what we're doing right now is creating the latch. This is the inside portion of the latch, and this is going to be the outside one. I think like 2mm might be too much. We'll just have to see. And of course, we also need some sort of grip over here that we can just pull this tab out with. Let's see. What am I trying to do? I don't know anymore at this point. I'm just going to sketch this stuff manually. C? No, C is circle. What is coincide? I for coincide. There, let's make this some millimeters so that we have some space down here. This guy goes to this guy goes down there, perfect. So there is our first version of a latch. Ooh, Blender. Blender. I mean, okay, there are a few different CAD approaches, I'd say, that you can take. I've tried using Blender. I think it is a great tool. I use it occasionally for just, you know, playing with STLs that you can't modify any other way. I do use it for that, but for everything else, I think it's just not a great tool to use. Well, unless it's like artistic 3D modeling that goes to graphics and rendering. But like for making parts for 3D printing that are supposed to have a function, I just don't think it's a great tool. I don't think the modeling approach is suitable for that. This sketch is I said this was going to be a single sketch part, but this sketch is turning out to be pretty complex. Okay, 5 is too much. Let's stick with 4. Do I need to explain more about what I'm doing here? This ledge moves up. Okay. Can I make a fidget spinner, please? Somebody ban that guy. I'm not making another fidget spinner. There are plenty of designs to download, and it's just not something that I find is valuable to do at all. Let's trim these guys up. So that's gone. Now, okay. One last basic, like I'm gonna call it quits. No, one more thing to point out. Everything that's blue in the sketch requires me to drink tea. Anything that is still blue in the sketch is under constraints, so I can pull these in one way or another. It might not be, you know, like right here, I can still pull these out, but I cannot pull these up and down. Because somewhere in this chain of constraints, like there's 2 millimeters, there's a 1, somewhere in this chain of constraints, the height of these parts is constrained. But I can still slide these left and right because they are missing a dimension. I'm just seeing this guy should be horizontal as well. So like I can still pull this guy up and down and change the total height there. And I can pull it left and right. And everything that's black, that's black is fully constrained, so I cannot pull these. These are fixed in place by dimensions or otherwise. So that is something to know about any CAD. I think pretty much any CAD does it like hiccups. Pretty much any CAD does it like this. I might have the mic to mute the mic. Okay, most of these dimensions are pretty much bullshit at this point. This is just, you know, by feel, by you know, by how I think this stuff should look. To have it make sense, it might be different dimensions. I agree. The 0.5 millimeter gap. I still need to add this notch in the back here. This design is just not turning out the way I wanted it to. Like this lever part back here is a lot larger than I thought it would be. Let's just see if it works. So we need a height for this guy. So at which position this is going to sit. I think around here. I'm still going to add a dimension just to make it smart dimensions. Awesome. Just to constrain it properly. Tessa, you're welcome to send me mugs, but if you it's hard to find some that hold like half a liter of tea. That's like the doses that I need. It's hard to find mugs that large. I would be using some, but I don't have any decent ones that are large enough for me. Let's see, 5, does that make it too slim down here? It does not, but everything is constrained. One last thing is we need to add the notch for the living hinge, and that's just going to be a center point rectangle. Let's add a point first and constrain that point. This is auto constrained. Now we can use this to center it perfectly. Dimension this to have a hinge exactly 0.6 wide. That should 0.6. That's the one thing Onshape needs to fix. You can't use commas, which is the decimal point unit separator in well, here at least. Let's make that to, let's see, this is going to depend on the exact material you use. Bye. Oh, that deleted the dimension. Okay, let's not do that. Let's just select this area and extrude it. Width 3, 5. Okay, it is going to get a screw hole in the bottom here. So maybe 10. 10 should make sense. And it is going to be printed this direction, so this exact direction facing up. Yeah, looks good. STL fell off a mug. I've actually thought about that, like the ColorFab HT or Triton, which is the, well, Tallman Triton, which is the same material, is a material that is okay to use for food. It is used for clear containers, etc. And this dishwasher is safe, apparently. The only problem is the layer structure. I don't know how much grime that is going to take up over time. Oh, I see what you mean, Brian. Marcus. Yeah, Bavarian complaining about mugs that are too small. We do have these large glass ones, but I don't think they are like heat proof. So I don't think you could just dump some boiling water in there. Worth a try though. Okay, planes. Let's get rid of these. Again, I'm just gonna use a. Oh, hold on. I just realized I used the one-dimensional extrude. I'm just going to stick with symmetric because that means our center point, our origin, is going to stay exactly in the center of this wire through hole. And we can just sketch on top of this surface, align our view, create a circle, and this is going to be perfectly centered for a through hole, for a mounting hole. Dimension this to 4 again. And of course we also need to extrude it. And here's the beauty of that feature again. So it's the same feature that would create a an extra part, but you can also say remove, and now it's cutting out that same section. We need a counter bore. Let's see. I think we should be doing this differently. Let's get rid of this this sketch. Let's do a, how is this called? Revolve. A revolve feature. This is going to be a single feature that also includes the counter bore. So for that, we need our planes again. P to enable planes. And we're going to sketch on the top plane. All right, so a revolve feature is essentially a feature that has a that has one contour that spins around a center axis. Why not use the whole function? Why not use the whole function? Because I would have to create a point exactly on the surface, and I don't think the hole creates a countersink that works correctly for these curved surfaces. That's why I'm not using the hole feature. It might make sense, it might work, but I want to show you different ways of doing things. So, center line, that is going to be our, and it's neither perfectly centered there nor here. This is going to be our axis that this thing is going to revolve around. Key to turn it into construction line because we're not going to be using that. Well, I guess we will. Now, we do probably need to align these like this. Okay, that's going to be our outer edge because we don't want to revolve into this side surface. I guess we could, but I don't want to do that right now. Right there, then we're going to have a 45 towards the center, then the whole end back. There are different ways to solve a problem there. There are many different solutions. I'm just showing you one of them. Feel free to use this tool in whichever way you feel comfortable and in whichever way you feel works for you. and this dimensions towards the center line. And because this center line or a construction line is usually something you revolve around, it can create these symmetrical dimensions very easily. That just allows you to I guess I could have just gone with a full-size carnivore. That does allow you to create a diameter dimension instead of a radius one. And one last one down here, 0.5. I guess I could have made this completely flush, but yeah. And there is our well, tool for the revolve feature. And revolve axis, this one. Is this that crappy shit? Is this the 0 thickness issue over here? It might be. Add. Oh, add. Okay, I don't want to add. I want to remove. Here we go. Now it's working. Yeah, so this is one of the issues that I know from SolidWorks. I thought Onshape was a bit better there. But if you create a new part that just barely touches, that just barely grazes another part, that essentially creates an infinitely small gap between them, the engine behind these cannot handle it. It just can't do it. It can't wrap its head around it. Even though in practice it could work, I think in reality you could have something that has an infinitely small gap. The engines just don't do that. Thank you for the €10 donation, or tip, I guess is the lingo there. You want to join it? Whatever, much appreciated. Remove, yeah, but that's what we're doing here. Removing that. It is a bit too far up still. It's still cutting into the top section there, which we do not need. So, and this is constrained to the top here. So what I'm going to do is just add another line right there. This is still going to cut out the top there. It's just taking both of these sections. But what we can do is we can remove the sketch 2, which is just taking the entire thing, and just select this section right down here. And it does not cut this part up here. If you select it, it does. If you deselect it, unselected, it does not. So that's... okay. I was wondering about this curve right here. That's that. That is... exactly what we wanted. Planes, goodbye. And again, if we go into the section view and section right through here, this just creates a seat for whatever countersink screw that you might use, and kind of, you know, countersinks it. It might still rest against whatever cable you clip in here, but it's gonna be better than not countersinking it. Mike's Tech World is asking, do I plan on reviewing the Prusa multi-material extruder? Yes. The thing is, so far it just hasn't been released yet. There have been a few beta parts, and as usual, I do not like to work with beta hardware because of, you know, all the strings attached to it. And it looks like it is finally getting to a state where it is usable or release worthy. Cool, that works out perfectly. Now, chamfers, fillets, etc. is something that I, usually like to add at the end, because if you keep them throughout the entire design process, you might, lose a bit of geometry that you might need to sketch onto, to use for other features, etc., etc. So yeah, that's something that I typically do on the very end, and I think it makes sense that way. This part is pretty much done. I'm just going to remove a bit more material right here with those chamfers. I think right here, that might be a bit too much. I know this is not the cleanest approach, just reshaping your part with chamfers and fillets, etc. I find it usually works pretty well. 10. Find it usually works pretty well, and it makes for some pleasing geometry usually. There's a lip to put a finger into. I'm I'm not sure if this is actually thin enough to bend away like this. We could run a simulation, but I've not done that in Onshape yet. Let's see, maybe if we, let's see if you can go back into the sketch and just make this top surface a bit thinner. Ah, again, ha. Cool. What we can do is just create another, and it previews the final geometry that we're going to get. So what we can do, well, it overlays it on the sketch. What we can do is just create another line and use that selective extrude again. So another dot up here, so we can get a solid geometry, a solid sketch feature to sketch against. And I guess this could be another living hinge, but let's make it a bit thicker at 1 millimeter. Okay. And it auto regenerated. And now we can see fillet 2. This is again why I use fillets and chamfers words. Why I use chamfers on the end, because some feature modifications do tend to break these, and you usually do want to add these as soon or once you have everything else figured out. Fillet edge of chamfer. So this is working. This is working, but fillet 2 is not. Fillet 1, apparently, that's this one. Okay. Why are you not working? 10. Then that creates this ridge up here, so I'm going to split that into 2 different features. Another fillet, 5 millimeters. 8. Smooth that out real good. Okay, and I guess we could add a fillet to these edges right here. That's probably that's actually more than I wanted, but I think that is just going to work. Perfect. So that we don't pinch the cable once we close this. Sweet, sweet. Had a bit of a rough start this part. Bit of a too complex sketch. Maybe add a chamfer on this one just to make it less rough if you ever end up scraping it or grazing it with your hand. Yeah, I think this should be able to snap open. Right, I guess that is that is most of the CAD stuff I want to do today. So that is, again, that's just stuff that I want for my own desk to manage all those cables. So a multi-holder that has 10 individual slots, or more or less if you want it to be. A cable clip that is just a very, very simple single screw clip that is permanently attached, and a snap together cable constraint that holds a single cable and is easy to open and remove. Cool. Let's go through chat real quick. So what material will this be printed with? I guess nylons would work great for this, especially for the living hinge back here. PTG maybe not, because it's too brittle, but an ABS should also work. PLA maybe too. Some of the PLA plus, the impact modified ones that are just a bit softer than the typical ones. Has my plant been watered? Shit. That are a bit softer than the usual ones. Might be a good choice there. Has my plant been watered? This guy. Yeah, actually, yes, it has. Those leaves are just droopy like that always. Maybe add a fillet at the hinge. There are no sharp corners and it doesn't break so easily. Fillet right here, I guess, right there. It's just going to be a single extrusion line, so it's not going to be that that fillety anyways. Semi-flex, Ninja-flex, yes. Armadillo, I think, is the very hardest one, but the Cheetah, I think that is their 95A? No, 75D material. That is, yeah, good choice for that as well. Polycarbonate might also work, because again, this is just a living part. I could split it in two and add an actual hinge mate. But yeah, This guy totally doesn't matter as long as it's rigid. So any material, maybe not a soft nylon or a semi-flex, because this is just fixed at the ends and it's going to droop in the center if you do it like that. And this guy obviously doesn't matter which material you use, it just totally doesn't matter. Okay, there you change cable size on clip holder. What? Yeah, okay, again, all these parts are in the link that is in the video description right now. It is yeah, it is Onshape. It is public because, well, again, that's the free plan in Onshape. I see that already there are 4 copies of this design, so obviously people have found it, and obviously people have it working. You can access it. The hole in the right is for a cable. No, the hole in the right is for a screw and the cable goes here. But yeah, you can get these files. You do need an Onshape account to download them. I think if you're really interested in parts, I you know, just let me know in chat. I can put them on Thingiverse or Umagine or wherever. The idea was actually because this is like a do I have the word family or something somewhere in the video title? I don't know. But yeah, the idea is to have just a complete family of designs somewhere, somehow. For me, for you, for everyone, good times. Yeah, come on. But yeah, I guess that is good. Any more questions from chat? Or any other design that is not a fidget spinner that you would like me to design, or just to walk you through or explain the thought process behind that? Onshape intro, yes, it was another Onshape intro that I already sort of did once. Again, it's not about the CAD tool. It's not about the change the cable size. You think it'll break? I don't think it will. It might. Shit. I might have had a few wrong references there. But anyways, it's not about the CAD tool that you use. It is about the thought process behind it. This might mess some stuff up. No, what? What? Did we even use cable diameter? That's the wrong sketch. Did we even use cable? We didn't even use cable diameter. So yeah, it doesn't break anything, but we're also not using it. Cable diameter. So just as a yeah, right here the hinge is just, or the clip is just breaking. So let's not do that. Yeah, again, example for how a design can be set up incorrectly for parametric design. I guess I just got carried away, you know, doing this entire sketch. What could he change? Yeah, this dimension, this 5mm dimension should definitely not be registered towards the center. It should be towards this point right here. Let's change that. Let's change that. That feels wrong, just leaving it like that. So if you go right here and do 1, then it might not break. Then it does not break. Booyah. Maybe some of the chamfers fillets. Yeah, those break. And this guy is now huge. But overall, it's why is this not working? Edge of chamfer. Where is that? Here? Yeah. Look at that. It's working. It is parametric, somewhat. Yeah, chamfers and radii fillets do sometimes break, but yeah, you can make it parametric. You can change the dimensions here. 5 is probably going to break one of the fillets again. Yes, exactly. But function is there. Function is there. Okay. Questions, chat. Love to see that living hinge printed. I would too. Maybe make a video about it. Hey, I printed this thing, and I designed it, and I think it's pretty cool. I should have. Oh, okay, I can crop the. I was saying I should have recorded the Onshape process separately, but I can just crop it from the live stream. Cool, and I'm recording. I might print it. Yes, I will. I will definitely print it for me because I need these parts. Don't make the stream too long. Yeah. Do I have an M3D printer? No, it's not. It's not about getting you blocked. It's just about I'm not reading chat. Do I have an M3D printer? No, I do not. Wasn't that like that completely failed Kickstarter thing that's kind of delivered and never printed right? But yeah, I do not have one. Elephant cable holder. Yeah, I guess it looks like that. I mentioned OpenRC F1. Will I be making a video printing that? Well, just printing it is boring. Making it and actually having drive, that would be cool. I would like to do that. It's getting warm here. I went on a nice bike ride. You know, sun's coming out. You can do stuff outside. That's what I'm trying to say. Would be cool. I might. I want to. I just don't know if I'm gonna have the time. Gosh, chat, too fast. Is it possible to export these to Thingiverse as parametric STLs straight from Onshape? So STLs are not parametric. STLs are just your triangular. Let's actually download this guy. STLs are a fixed design. They are not parametric at all. They are your triangular. They are triangulated. That is, yeah, that's the core of it. They are a fixed shell. If we head into repair, you're actually going to be able to see all the individual triangles. That is what the STL looks like. It has no information about the parameters that we use to design this part. It has no information about, you know, the features used in this part. It is just this shell. So yeah, unfortunately we cannot export it as an OpenSCAD file. There might be a plugin for that. I'm not sure, but in theory, I guess you could export it as OpenSCAD. But like right now, there is no way of natively exporting this to another format and keep the parametric nature of the design. Next build along should be a hypercube. Next build along is going to be a hang printer. How hard is it to learn Onshape versus Inventor? It looks similar. It's not about learning the exact tool. Onshape is really easy to get into. I mean, it just shows you the tools you need. If you know one CAD tool, you can use them all. If you know, well, maybe not CATIA. But if you know SolidWorks, you are going to be able to use Fusion. If you know Fusion, you can use Inventor. If you can use Inventor, you can use Onshape. It's, again, the tools are the same. It's not about the tool they're using, it's about the thought process behind it. That's what I keep pointing out. So yeah, I think Onshape has a you know, shallow learning curve. Is that how you say it? Yeah, it has a shallow learning curve that doesn't, you know, expect too much from you at the start. But yeah, in general, it's pretty easy to do stuff. Hang printer on a large tripod. I don't have a tripod large enough, but I was thinking about that. The problem is the hang printer was explicitly designed with no tripod or no structure at all needed, so that kind of defeats the purpose. Any chance to see an LCD-based OpenSLA live build? Maybe, if I find one that's going to work. But yeah, that should be... Like, okay, it's 2 minutes, yeah. But that should be it for today. Do I have a preferred CAD software? Yes, this guy. CATIA V4. Yeah, good memories using CATIA. Oh, God, yeah, the industry is slow at some points. But yeah, that's going to be it for today. Thank you for being here. It was, wow, 2-hour stream. Yeah. Thanks for being here. Thanks for hanging out in chat and for the questions asked, and yada yada. Stay tuned, subscribe, Patreon, tips, whatever. By the way, oh yeah, it is working. Cool. So down here, the subscriber overlay, that is Streamlabs. Cool stuff. yeah, but have a nice evening. If you're in any region of the world that does the entire My Bomb thing, have fun stealing them and getting them back. That's an awesome tradition, I think, and enjoy your huge ass trees being put up tomorrow. I am definitely gonna go watch one. But yeah, whatever other traditions you might have, enjoy them. Tomorrow is a holiday in Germany, so day off. I wish it was. But yeah, thanks everyone for being here, and that's gonna be it for today. Have a nice evening, day, morning, afternoon, whatever it is for you. Goodbye. Which button? Stop streaming. Yes, stop.